Land is one of the three major factors of production in classical economics and an essential input for housing and food production. Thus, land use is the backbone of agricultural economies, and it provides substantial economic and social benefits. Land use change is necessary and essential for economic development and social progress. Conversion of farmland and forest to urban development reduces the amount of land available for food and timber production. Soil erosion, salinization, desertification, and other soil degradations associated with intensive agriculture and deforestation reduce the quality of land resources and future agricultural productivity. As urbanization intensifies, agricultural and non-agricultural land use conflicts became more severe. This may lead to an increase in local ordinance design to force farmers to pay for some of the negative impacts generated by agriculture. As the nearest input suppliers close because of insufficient demand for farm inputs, a farmer may have to pay more for inputs or spend more time to obtain equipment repairs. Land use change is arguably the most pervasive socio-economic force driving changes and degradation of ecosystems. Deforestation, urban development, agriculture, and other human activities have substantially altered the Earth's landscape. Such disturbance of the land affects important ecosystem processes and services, which can have wide-ranging and long-term consequences. Globally, buildings are responsible for approximately 40% of the total world annual energy consumption. Most of this energy is for the provision of lighting, heating, cooling, and air conditioning. Increasing awareness of the environmental impact of carbon dioxide and chlorofluorocarbon triggered a renewed interest in environmentally friendly cooling and heating technologies. The way we use resources provokes often irreversible ecological change. Extraction and processing of non-regenerative raw materials are often energy-intensive activities involving large-scale intervention in ecosystems and the water balance and result in air, soil, and water pollution. Even the extraction and production of renewable resources often involve extensive use of energy, materials, chemicals, and in some cases water, and all this translates into pollution. Greenfield land is often transformed to create arable land, and in some cases, whole ecosystems are destroyed in the process. In short, raw materials extraction and processing always impact on the environment, resulting as they do in soil degradation, water shortages, biodiversity loss, damage to ecosystem functions, and global warming exacerbation. And that's not all. For the use of products made of raw materials almost always results in greenhouse gas emissions, pollution, ecosystem damage, and biodiversity loss. Products need energy and water, as well as land for shipping, marketing, and use. Improper product use provokes noxious emissions that can end up in our water, soil, and air. The very infrastructure elements that we take for granted, such as our homes, not to mention countless daily activities, often involve extensive resource use and result in greenfield land being paved over, damage to ecosystems, and spoiling the beauty of nature. Energy's effect on air quality in a number of ways, including increased urban pollution caused by switching from gasoline to ethanol, the effects of hydrogen foil on air quality, and reducing indoor air pollution through energy-efficient buildings. Researchers are studying the impact of existing energy systems on climate change, as well as solutions for reducing greenhouse gas emissions. Key research areas include carbon capture and storage technologies, the role of nuclear power, the impact of biofuels, and the feasibility of converting to wind, water, and solar energy on a massive scale. Most traditional energy technologies and some alternative ones consume a great deal of water, and they can affect the quality of fresh water supplies and coastal resources. Scientists investigate the use of coastal shores for liquefied natural gas export facilities, the hydrologic pathways of food contamination from coal-fired power plants, and the economic interactions of energy and water supplies. Renewable, environmentally friendly energy must be encouraged, promoted, implemented, and demonstrated by full-scale plant, especially for use in remote rural areas.